So let's look now at the Vanoy Manistability analysis for the donor cell scheme using again a single Fourier mode as we did before. Again, putting this ansatz for the density onto the recurrency relationship, then this is the scheme that we have. I have the amplitude in the future, the current amplitude, and the exponentials here are at the point I, so that's just exponential of ikx. But here we have the upwind point, so that's x minus delta x. Again, multiplying by the positive exponential, we have this recurrency relationship. Now, the amplification factor is this, is 1 minus c plus c times the exponential. If we expanded this exponential into cosine and sine to have the real and imaginary part, let's split that into the real part and the imaginary part. Call the real part b, 1 minus c plus c cosine k delta x, and the imaginary part d, which is c times the sine of k delta x. So we can write the amplification in this form, and if we now multiply by the complex conjugate, then this is the equation that we have. The amplification factor is b squared plus d squared, which we write in this form. Now you have here the amplification factor. You have a point which is 1 minus c squared, and you have this other term here, which multiplies by the cosine of a quantity. Now this term here, the cosine, is bound between minus 1 and 1. That means that the amplification factor is bound between the value of this quantity when the cosine is minus 1, which is this, and the value of this quantity when the cosine is plus 1, which is this. Now we want the amplification factor to be below 1 for stability. So we take the maximum value, which is this one, and require it to be less than 1. Now this factor here becomes simply 1 minus c squared. So what we want is this factor, 1 minus c squared, to be bound between 0 and 1. So this is true as long as c is less than 1. Remember that c by definition is a positive quantity. And this is the stability condition of the donor cell scheme. The Courant number must be less than 1. So upwinding seems promising to achieve stability, but the accuracy has to be improved because, as we see, it's being severely smeared.